So functions are useful and very important. For example, sine, cosine are all built in, right? Print is also a function, okay? And input is also a function. So you've seen many of them already. Let me get this in this mode. So the two important types are value returning and void functions, okay? Void means they do not return a value. Sometimes they're called script. In fact, Python is known as a scripting language. I don't know why exactly, because it's not compiled or something. So the best thing to do is perhaps run a couple of examples. Then you'll get a much better idea of what I'm talking about. So let's go to Python 3.3. Where's Python 3.3? Here we go. And if you go to that folder which I have on the Y drive, you should be able to run. Let's see, where's the folder on the Y drive? Here's the computer shortcut, Y drive, Spring, code samples. So out of these, if you see anything which says function, it probably is an example of a function. Here, function. I don't see any other, so let me run that, okay? Okay, I'm glad it's in color, that helps a little bit. And I'll make it bigger if I can. No, it's not changing the size. Okay. A definition of a function comes first. Then you can call the function like in this place. So I'm calling it with the constant value 5, and calc square is supposed to square that number and return the answer right here. Okay. So we expect to print 25. So this is a value returning function, right? Because it returns the answer 25. And the execution of the program begins at this print statement. But then we call the function right here with the parameter 5, which is assigned to number. SQ is assigned number times number, which is 25, and we return SQ. So it's a value returning function. This is the name of the function, just an ordinary identifier name. And it prints 25. So here we enter a number, integer, and then we are going to calculate the square of I, which ranges from 0 to n actually, because n plus 1 is 1 extra. And then we are going to calculate the square of 5.5. So this doesn't care if it's an integer or a float. Okay? So let me run it and show you the output. 25 first for this. Now it's waiting here for the number. Let's put in 10. So I expect 10 output lines from here to here. 11 I guess, because it said 0 to 10. 11 actually, and it doesn't do the 11. So any questions so far? And then finally we print the square of 5.5, which is 30.5. So the reason I did this was the same function calculates the square of 5 or 5.5, real value or integer value. And then you can call it in a loop like this. So what's the advantage of function once again? You can write it once and use it any number of times in other programs too. Right? Can you not cut and paste it somewhere else? Can this be as complicated as you want? Can it call other functions? Yes to all of those. Okay?
Question.
Yes.
When you save a function, I assume you save it as its own file. Is that a true statement?
We save the whole thing in one file. So the function is not saved alone because you could have 10 different functions right here. Okay?
No, I'm sorry, I don't understand.
You don't understand, okay.
But that function only works in
this
that
file,
window.
yes.
It won't
It won't transfer to any
calls.
other place. because this is a local variable, so it's known only to this program. I think I remember one more example, so but go ahead, ask your
Okay,
question.
well, and still holding on here.
Okay, let me run the
What?
second example, maybe that will help. I think it's called example 4a. I remember it has a function, so let me just open it. We'll have both open. Okay, this one has a function called getValue, and it ends here because of the indentation, right? And it's called somewhere here later on, getValue. Where does it say getValue? Do you see getValue anywhere here? If you don't call a function, nothing happens, so getValue. Oh, this is automatically executed when the left button of the mouse is pressed. That's why you don't see any calls. Okay? So you can have functions which can be based on an event. But we've not done events, we've not done object-oriented programming, but let me run it anyway. Run module. So it makes this little GUI. If anybody's bought a car recently, let's say $20,000 loan, and 5% interest, 0.05, and for 5 years, then had I put this much money aside at 5% interest for 5 years, how much would I make? 25,525.60. So when I press the mouse on this button, that getValue is done automatically. Okay? Now let's see if we can answer any of your questions.
I don't understand
Okay.
what makes the connection between your defined function
Okay.
and the program.
Correct. Okay. Again, if I remembered, I would tell
I mean,
you.
obviously, you defined it as calc square, so when in the main program you say print calc square
Right.
5.
Right.
How does the 5 get into the function?
It's assigned to the variable called number. And you can have any number of
That
parameters.
occurred where?
As soon as you call it,
Oh, okay, I understand. It's
it jumps to that function.
It's the structure.
Pardon me?
The structure calc square.
Yeah, calc square is a name. It
Got
has
it.
to match
Okay.
exactly. And when you call it, this is the call actually.
Gotcha.
And execution begins at the print statement. And 5 is first assigned to all your parameters here.
Gotcha. Okay.
Okay? And let me complete the PowerPoint. Hopefully that will clear some of the questions. Okay? So let me jump a little bit here and there. Scripts. Don't worry about scripts. They're independent piece of code or a function. Okay. Function is a self-contained piece of code that performs a task. Okay. It can be triggered by a mouse button automatically, like getValue, and it can be triggered by calling it. And it may or may not return a value. So we'll see all types here. In pseudocode, you write function. If it returns a value, what type of value does it return? Name of the function. There should be a space here, but you know our PowerPoint slides are not accurate. So you have any number of statements. At the last statement, you put in what it returns. Okay? And this is how you call it in the main program. This is where the execution begins. You can assign the value it returns to a variable. But again, this is sort of vague. And this is also vague, but this is how you would write it in a flowchart. Even Visual Logic has functions in it. I'm not going to go through too much of it, but you can try it out on your own. And it's not as important for the last test, by the way. So this is a call to the function indicated by double lines here. So when you come here, parameter 1 is passed on to parameter 1 here. We should have called it different things. Parameter 2 is given to parameter 2 and so on, n to n. Then it jumps over here, does all of this, it returns the result which should have been calculated inside of this. So the value of result is going to be assigned to variable and then it continues execution. So again we need to make it concrete. In fact, there are more complications. There's something called call by value and call by reference. We will not worry about call by reference in this class. You'll probably see it in more advanced classes. So call by value is what we use. This is just the heading of the function. Some comments to indicate what it does. And again, we are coming to the example in just a minute. For example, we've seen input, which is a function, takes a string as parameter and displays the string, reads in something from the keyboard, convert to integer. So these two are functions. Or float is a function, converts the character string into a number. So these are called built-in functions. Again, we are wandering around too much. Let's get to the example, okay? This is the same calc square I just showed you. In flowchart form, you would call it like this, calc square of 5. And it could be more complicated, plus 7 for example. But as soon as you hit this, it jumps over to this, does this, returns the result. We should have called it something else here, answer or result somewhere, okay? And then print it out. So this would not succeed unless we had actually calculated a valid value, right? Could be a string, could be float, could be integer, it doesn't matter to us. So again, this is the Python code. Let's go over it carefully. There should be a space here. The name of the function is calc square and it does return an answer. You can have an expression down here. Now the main program begins here because of the indentation, right? So it calls calc square with the value 5, which is assigned to num. Num is an ordinary variable local to this function. It's not known beyond this, okay? You learn about scope also later on. So it calculates num times num, gets you 25, which is returned right here in place of this. So result is assigned 25, and that's what gets printed out. Now, is it okay to call this num, for example? Yes, but it will be confusing. These two are different nums, okay? Right now it's clear, this is a different variable from num. Okay, let's keep going. We'll finish this and we can come back to those. Now, this is a pseudocode again for a function which returns a number as an answer. Numerical is just the pseudocode for returning a number. Calc average. It has 3 parameters and it's returning the average of the 3, right? Divide by 3.0 to indicate a real number. Okay, then you're calling it with this 2, 3, 4. So execution begins here. Functions are skipped over in pseudocode as well as flowcharts or whatever. And you come to the main program. This is called the main program. Calculate the average of these 3. The result is 3.0, right? And print the result. So this is what it looks like in flowchart form. And if you are curious enough, you can do the same exact thing in visual logic. Side by side, you have a function definition. Once again, you can have many function definitions. It doesn't have to be just 2 flowcharts, but the main program always has a start on it and a stop. Okay? So you start here, you call calc average with 2, 3, 4, which get assigned to num1, num2, num3. That's called by value. It does this calculation, put the answer in result, return that. Whatever these 3 numbers may be, they could be real also. Then that answer is assigned to average and that's printed out. Okay? So execution continues where you call the function exactly here. If I had plus 10, it would continue with the plus 10, calculate the plus 10. Okay? So let me finish this very quickly. There should be a space here. The name of the function is calc average. X, Y, Z are 3 arbitrary, poorly named parameters. I would use longer names, right? And then it returns the average. So you can call it like this, or with 2.5, 3.5, 4.7, anything like that. Calculates the average, puts it in result. So execution begins here, because that's the definition of a function, right? And print that out. So Python is very brief in defining a function or executing a function. Now I can have any number of these type of functions. Can I have 8 or 10 of these? Yes. And then I can call upon any. Can a function call another function? The answer is yes. But it has to be defined previously. So I can call calc average from here but I cannot call it from here. Try it out, please. It's all very simple, but it's confusing unless you give it a try. So another example, we are going to write something called minimum, which will calculate the smallest of two values. In pseudocode, this is a function, it returns a number, it's called minimum, it takes two parameters. If this condition is true, then value 1 is assigned to min, otherwise value 2 is assigned to min. So it calculates the minimum, this is the end if, and it returns that. Now, I think in our code coming up, I may have used the same name here and here by mistake. Let's see what it is. But in flowchart form, this is just the flowchart for that function. The main program comes here. So you're comparing value 1 to value 2. I don't need the if, it's obvious here because it's a test box. Assign one or the other to min and return that. If it was max, then this would be greater than, right? And here's the function. Now the mistake I have made is calling it min here, and this is a separate variable. Unfortunately, Python allows you to have the same name for a function name and a variable name. But the logic is clear, and this should be indented, by the way. All of this should be indented at least one space over. Otherwise, it will think of this as the main program, right? So we have a few mistakes here and there. If value 1 is less than value 2, then you assign that to min. Otherwise, you assign value 2. So does it in fact calculate the smaller of the two? It does. Now, if these were strings, it would still work. And Python doesn't care if these are strings, numbers, or something else. Main program begins here. The line below calls the function min. So that's the min being called with 5 and 15. So it should return the answer and replace all of this with 5, right? Which is assigned to minimum, another variable, which gets printed out. Try it, please. And this output. So if I give you something similar to this to trace, and I label this A, B, C, D, which one will get done first? D, exactly. But it will be done partially because it's going to call min. So what's the next statement that will be done? A, up here. And then because 5 is less than 15, the trace will produce this statement, B. And therefore it's a snapshot of what's happening. If you do want to trace every single line, you can do so automatically in Python. I've forgotten how to do that exactly, but you have to set one of the debug options on or something. So this is a void function. In C, C++, they use the word void to indicate it does not return anything, that's all. So we use the same thing, and it has a return, nothing after it. So it may have some print statements, otherwise it's useless, right? If it doesn't produce any output. And it's done similarly over here. Just a plain return with nothing in front of it. Function name, there's something wrong here, spelling error. So write a function calc Fahrenheit, which will receive something and print the equivalent Fahrenheit temperature. So this is a useful pseudocode thing, and this is the calculation part. 9 by 5.0, so that it doesn't do integer division, times Celsius plus 32 is the formula to convert a Celsius reading. For example, 100 would be 9 times 20, 180 plus 32, 212, right? And just a plain return because you're already printing the answer out. So it does not have to return the answer. And here it's not in an assignment statement, not an if statement, not a print statement. You just call this function like this. Say you call it with 40, it'll be 40 here, right? 40 is assigned to Celsius. And that's 8 times 9, 72 plus this 104. You should print 104. And execution again begins here at this point. But this is all pseudocode. And this is the flowchart, the main flowchart. The 2 bars mean you call a function. which begins here, always have the name of the function here and the list of parameters, print something and return. No answer is returned. So it comes back here and continues execution. Okay? So see how small it is in Python. There should be a space here. Name of the function is calc Fahrenheit, Celsius. And it just prints this. There's no need for return either, because it just automatically returns at the end of the function, which ends here, right? Because of indentation. And this is the main program, calc Fahrenheit with 40. So when you do this main program, if I number this 1, 2, and 3, execution begins at 3. 40 is assigned to Celsius. So I do 1 next by doing the assignment. And then I do 2, which does the calculation and prints, what is it? It prints 8 times 9, 72 plus 104. It prints 104, comes back to the statement after 3, which isn't present, right? So 3, 1, 2 is the sequence. One other example, there's a void function, so it prints 3 things, and those 3 things are the 3 parameters here. Prints the name, so it expects 3 strings, prints them all out. This plus is for concatenation, and does a plain return. The main program is not shown here, but you would print something like print info, John Doe, etc., date, and the project number. If you have any questions, I'll be happy to go over this again. But again, we have a mistake here. There should be a space before print info. That's the name of the function. Does not return anything because it has 3 print statements and no return. So it does all this, but before doing that, it does this statement, number 6, first. Assigns John Doe to name, 6/10 a string to date, and this string to project. It just prints them all out, and that's the output. Okay? So if these are not on the code samples thing, how long does it take to cut and paste and run it? Very little time, right? So I expect you to do that. And finally, this prints a triangle of stars. Remember the stars we had in an earlier chapter, and this is a new line. So you type in the height, or give it the height. Suppose the height is 4. You print 1 star in the first row, 2 stars in the next one, and so on, up to 4 stars in the last row. Conclusion. You can read that yourself. Let me go back to the examples and see if we have any other on that. So I'm going to assume that you can run this yourself, and let me see if I can figure out in the next minute or two, otherwise I give up. By the way, this is more complicated because get value reads a number in one of the boxes, all of the boxes. See, it says text1.get, so it gets it from box 1. Text2.get gets it from box 2, and so on. So this is complicated, and you don't need to understand that unless you want to. This one, where's the shell? Okay. Again, the procedure is to, this is not the shell, sorry. Oh, it's here, right here, thank you. Debug. Debug allows you to execute this line by line. So let me show you if I remember correctly. Don't laugh, please. You go to debugger and it opens this window. Okay. Then you go to this and run the program. Run module. So it comes back and tells you which statement it's executing. It's at line 3, def calc square number. Okay. So it has already done this statement. It's assigning 5 to number right now. How do we know all that? Because in the next step, you'll see the value 5 for number. So step means go and execute the next line. Oh, so it jumped to line 7. I'm sorry. At line 1, it didn't really do anything. Line 7 is the first thing it does, right? I've forgotten exactly. So step again. Now, do you see that the value of number is 5? Not quite. But it's doing this statement, right? To see the globals, That's not it. The locals should be here somewhere. But
There's number 5 on the bottom.
oh yeah, I'm sorry, I just overlooked it. My eyesight is getting worse. So number is 5. It did the assignment, now it's going to do the calculation. It's at line 4. So step again, it's at the return SQ. And as you see that SQ is 25. So this produces a trace but very slowly. Instead I do the following. Of course over means you step over the function. Don't go through the details but just do it and come back. Okay? And then quit of course hangs up in the middle. I don't know what out does. Anyway, it's up to you to figure out all this. I used to cover it, nobody followed it, so I stopped doing it. Not a good idea. So what I do is just put print statements. Before this I print number. After this I put print SQ. And then to produce a trace you can always say what the line number is, right? Print the line number as well. So I would print this line number 1. Here I'll do one example. Let me go back. Something like that, okay? And then you can obviously fill it up with similar prints. I have to save it, right? I should save it automatically. What? I put the print in the wrong place. Tab.
Expecting an indent.
Yes. So it was thinking that's the main program. Okay, here it is. The debug is still on, so I need to shut it down. I think, okay, you can toggle whatever. Oh yeah, I have to kill the program. Control C stops that. I think it does. It's not doing it yet.
You gotta go to idle.
Debug quit.
Go to idle.
I am in idle.
Oh, yeah.
When you're clicking down there, you can't click directly next to the arrows. You have to click one over it.
There we go.
Okay, then type Control C. I give up.
Try going to shell and see if it has a restart shell.
Yes, it does. Thank you. I'm still in debug. Oh, debug is off, fortunately, somehow. Okay, so we go back and run it one more time. What's it waiting for? I don't even know. Should I print it at line 2 somewhere, which I don't see. Each time we call it, okay, this debug is acting. I know what to do. Just close this.
Yes.
That's the problem. See, the program is still running. Do you want to kill it? Yes. And I need to close this also because it runs it under 2.7.8 and all that. So unfortunately, life is not simple, right? You have to open it again. Recent files, fortunately. Okay, it saved it correctly, so we can run it now. And I just like it this way. At line 2, the number is 5, produces this. Now I enter a number, so if I enter 10, it's going to produce 10 lines of output. And it's repeating the trace for me, right? At line 2, number is 0 and so on, up to 10. And the output of that is. So that's what I expect on this test. Test, you've got to trace something, right? So I want to see the output and fill in the table for the trace. And I'm certain you'll have at least 2 problems like that on the test, okay?